Hey, all right, so I just wanted to give a quick demonstration about this value 1 plus, well, in our video before it was 1 plus 1 over k to the k. To use Desmos, I just flipped that to an x. It didn't play that nicely with k. So we're going to look at what happens to the quantity 1 plus 1 over x to the x when x gets really large, and then compare that to the number e. So Desmos will quickly graph it, and we can see that, oh, look, it is flattening out. So it is tending to a number. And if we put on f of x equals e, we can see that it's getting really close to e. And to even verify, we can check e minus, let's call this one g of x. And we can see that that gets super close to 0. So as we go far out, we can zoom in, and we see that even around 75, we're about a 200th. So that would be if we chopped our day up into 75 intervals. Maybe we chop our day up into each second, which is a huge amount of intervals. Be like less than 1/10,000. So if it was chopped up into every second, that'd be less than 1/10,000th. And on 1/10,000th, we're about, Desmos can't even detect the difference between 1 plus 1 over x to the x and e. It's just saying it's 0, even though the value is actually not 0. But I think if we zoom in, we can't even see the difference between the red line. Maybe ever so slightly. Yes, there's still just a small gap, but it says both of them are the same number. All right, so the other thing that I just wanted to show you is using Wolfram Alpha to find E. Wolfram Alpha doesn't play that well when you just type in E. It says just assume E is a character. If we do e to the first power, it treats it as a number, and e to the 1, like any other number, is just itself back. And we can see that it has this long decimal approximation. And like pi, it doesn't terminate. We can hit more digits to see even more digits of it, or more digits. And it just goes on and on. In practice, though, when a computer is evaluating these numbers, evaluating e to the something, it's probably just using like 2.7182 or whatever level of precision you need. Probably no more than 12 units are necessary. I know even in physics, when they're using the number pi, because that doesn't terminate, physicists have never needed more than, I think it's like 20 digits of pi to calculate even the most wildest of computations down to that might be stretching across our galaxy and calculating them down to a scale that would handle it for something like meters on Earth. All right. Well, that's the introduction to E, and seeing that E really is that function taken out to many iterations. All right, see ya. Oh, guess we're still recording because